Hi everyone, in today's video we are going to solve a problem squares of a sorted array. In this video first we will understand the problem statement, then I will discuss multiple approaches to solve this problem, and finally we will write its code. So let's start with the problem statement first. So in this problem we have given an integer array nums sorted in non-decreasing order, so sorted in ascending order. We have to return an array of the squares of each number sorted in non-decreasing order, so sorted in ascending order. So let's take an example to understand this problem statement. So in the first example, so given an array which contains both positive and negative integers, and after doing the squares of each number of an array, we return the final output array which are sorted in ascending order, which are sorted in non-decreasing order. So in the second example also, we have given an array which contains both positive and negative integers, and after doing their squares we have returned the array which is sorted in ascending order. So this is the problem statement. Let's discuss multiple approaches to solve this problem. Let's start with the easiest approach, and the easiest approach is to simply do the squares of each number of an array and after that sort the array. So let's do the square of each number of an array, squares of each number of an array. So here we get 16. After doing the squares, after doing the square of -4, here we get 1, 0, 9 and 100, and after that sort this array, and once we sort the array we get the array which is sorted in ascending order, right? So this is their code and it is very straightforward. We just iterate this array, we do their square and finally sort this array. Now the time complexity of this approach is big O of n log n, right? So in next approach, let's discuss how we can improve our solution to solve this problem in big O of n time complexity. Let's discuss our second approach, and also let's focus on some important pointers here which will help us to solve this problem efficiently. So in this problem, if the array only contains positive integer, then it would be very straightforward to solve this problem, as the squares of each number of an array is also sorted in ascending order, right? But the tricky part is the negative integers present in this array. So to understand this, let's take this example and do the squares of each number of an array. And when we do these squares, 16, 1, 0, 9 and 100. So this is the squares of each number of an array. So you can see for the negative part, for this part, right? For the negative part, we can see after doing these squares, the numbers are sorted in decreasing order, right? And for the positive part, the numbers are sorted in increasing order. So if we can view the negative and positive parts separately and iterate over both the parts, then we can solve this problem in O(n) time complexity using two pointers approach, right? So what I mean is, let's say we can first find the index of non-negative number in an array. So let's say index of this number. So this 0 is the first index from where the positive number starts, right? So what we can do is we can take two pointers. So let me just rub it. So we can take two pointers. One will start from the positive part and one will start from the negative part. So let me take this as I and let me take this as J. So here we are taking two pointers. One will iterate over the positive part of an array and one will iterate from the negative part of an array. So why we are starting from this index for the negative part and for the positive part why we are starting from this index? So I already explained. When we do the squares for the negative part, the numbers are in after doing the squares for the negative parts, the numbers are in decreasing order, and for the positive it is increasing order. So let's first find the index of non-negative array. So first find the index of non-negative number in an array, which is this index, and from here this pointer will move forward, from here this pointer will move backward, as this part is in decreasing order and this part is in increasing order, and we want the result which is sorted in increasing order, right? Now what we do here is, let's do the square of this number and do the square of this number, right? So it is 1 and it is 0. Between these two, which one is smaller? This 0 is smaller. And for this also, let's take one pointer. Let me name as P, which initially points to the 0th index. So between these two, the 0 is the smaller. So we simply put, or we simply write 0 in the output array and move this in pointer to the next index, and also we pick this 0 from the positive part, so advance this pointer also. So now this pointer will move at the point at this index and this pointer remain as it is, right? So again, between between 9 and between 1 and 9, which one is smaller? Definitely 1 is smaller. So simply put 1 here and move this pointer. So I'm moving pointer P. So now it points to the second index, and also let's move this pointer J, as we already consider this element. So now J will point at this index and I points to this index. So at this index the value is 3. So between 9 and after doing the square of -4, it is 16. Between these two, which one is smaller? 9 is smaller. So let's write this value here, move this pointer at this index, and also move the value of I, as we considered this element. So at this point, between 16 and 100, which one is smaller? So 16 is smaller. So let's write its value at this index and move the pointer P. So for negative part we are done. So we iterated all the negative values. For positive part we are left with the one value, which is 10. So simply do the square and write at this index. Now we get the array which is sorted in increasing order. So by using two pointer approach, this is how we can solve this problem. So let's see its code, and then in our next approach we again simplify this two pointer approach. But before that, let's see its Java code. Here is its Java code, and let me explain this code. So first I have declared one variable n just to initialize the length of this array, so length of this array. Then I have declared one variable. So as we have to find the index of non-negative number in array, from this point we can iterate the array in two direction by using two pointers. So first we iterate an array and find the index of non-negative number in an array. So we find this index. So here we assign this value 2, and then I have declared one array which is the output array, and after that there is here this is the two pointer, one to iterate on the negative part of an array and one to iterate the positive part of an array. So this will points the positive part, and from here we will start from the negative part. So first we find the point, we find the index of non-negative number in an array. So we found this index which is 2. So negative will start from the this 2 minus 1, which is from the first part. So that's why it is -1. So taking this pointer, and for positive part taking this pointer. Then we run a loop, and the condition is if the negative index is greater than equal to 0, we will keep iterating. So negative, because we are moving in backward direction, so this condition that it is greater than equal to 0, because at every point we are decrementing this pointer. And for positive index, for positive part, the condition is it should be less than the array length, as we are incrementing this pointer, right? Then we do the squares of each number present at this index. So at this index it is 1. After doing the square, at this index the number is 0, so after doing their square it is 0. And then we check which one is smaller, right? So if the value present at this index after doing their square, if it is greater than this part, right? So let me create positive, let me create one array as well, the output array. So 1 2 3, right? And here we simply copy the smaller part, smaller value. So it is 0, I mean this condition is not true, so we simply just copy this value 0 and increment this pointer. So this pointer move here. So this is the condition. If the square at positive index, I mean square at this part, is greater than the square of the element at this index, so simply copy this square value and decrement this pointer, else copy this value and increment this pointer. This is this is the condition here, right? Let me just scroll this code. So now this is the while loop. So we copied 0 and we incremented this index, the square at positive this positive index, right? And it is still less than n. Again we do the square and it is 9. We do the square, it is 1. Between these two, this one is a smaller 1, and we increment the one pointer here. We decrement this pointer as we already considered the value present at this index. Now we move this negative pointer here, so you can simply see this condition, right? And this index is simply this index. I mean, initially it is 0, so it's pointing at this index. Then we copied the element, then we moved this index, we copied the second element, then we moved this index. Now it's pointing at this index. So between 1 and 9, 1 is smaller, so we moved this pointer and we keep this pointer as it is. So in next iteration, still this while loop condition is true, as negative index is greater than equal to 0 and positive index is less than n. Now between 16 and 9, which one is smaller? 9. So we copy 9, move this pointer, also move this pointer. So in next iteration between these two, we simply copy 16 and we decrement its value, right? So after this, if we see, this condition is not true anymore and we came out of this loop, right? So there is two separate while condition here, and this one is basically, let me just simply scroll it. This condition ensures if there are any negative element left when this condition was false, we can simply do the square and copy this element in the output array. And this condition ensure if any of the positive element left, simply do their square and copy this element. So we are left only with this element 10. We simply do the square, copy this element and move this pointer. And after that, when we incremented this pointer, you can see this positive index is not less than n anymore, right? And after that, this condition is also false and we return the result. And this while condition, as we already covered or we already consider all the negative values, so this condition is not true anymore. That's why this while loop was skipped, and for positive part we are left only with one value. So this while loop run once and we copied this value, and after that we return the result, and this is the final output. Now let's talk about its time complexity. It's big O of n, and also its space complexity is also big O of n, as we have declared one output array. So let me rub it and you can see the code now, and which I have already explained. So this is the final code, right? I'll also share this code in the description section. So this is our second approach. Now let's improve our two pointer approach as well. So let's discuss our next approach. An alternative approach would be to traverse the array from both the ends. So let me take one pointer I here and let me take one pointer j here. So to traverse the array from both the end, and at every step check which pointer gives the highest square. Add the highest square to the output array and move the pointer. So why we are considering the highest square? Because when we do the squares of the negative element, we get the array sorted in decreasing order, and for the positive we get the array sorted in increasing order. So if we are traversing the array from both the ends, we have to consider the highest square, right? So now I will point at this index, j will point at this index. So the square of this element and the square of this element, so between 16 and 100, which one is the highest? 100. So simply copy 100 here, and let's take one pointer which points at the end of the array. And after copying this element, after writing this 100, we decrement this pointer, and also we decrement the value of j and keep I as it is. Between 9 and 16, which one is highest? 16. So we increment this pointer, we decrement this pointer, and we keep j as it is. So between 1 and 9, which one is highest? So 9. So after that, let's decrement this pointer and also decrement this, the value of j. Between 1 and 0, which one is highest? So 1. So let's increment this pointer, and I and j now point at this index. So now the output, so here after doing the square it is 0. Let's simply copy this, and after that we don't have to decrement this anymore, and we get the result which is sorted in ascending order. Now let's see its Java code. So here I have declared one array where, so I mean it is the output array and its size is equivalent to this nums array. Then I have declared two pointer. One is left index which start from this index, one is right index which start from this index, and this array index for the output array, the pointer will start from this index. Now we run a loop, and the condition is while the left index, this pointer, is less than equal to this pointer. So we take this value, the element present at this index and the element present at this index, we do the square, right? And then we check if this one is greater than this, then simply copy this value at this index and increment this pointer. Else simply copy this value at this index and decrement its index, and also for this index we also decrement its value for array index, as array index will point at this index. So after copying the value, we decrement its value. So this is what this code, if you see, so we are decrementing array index after copying the value, and for left pointer we increasing its value, for right pointer we are decrementing its value. So we do this, we run this while loop, and after, when we came out of the while loop, we return the result. So let's talk about its time complexity. Its time complexity is big O of n, and its space complexity is also big O of n, as we are using one output array. So that's it for this video tutorial, and I hope you loved this tutorial. So please like this video and share with your friends, and also please subscribe our YouTube channel for more such programming tutorials, as I started covering more topics related to data structure, low level design, system design. So in future I'll also try to cover different topics. So that's it for this video tutorial. Thanks for watching this video tutorial, and thanks for your time.